Okay, we have a ladder related rates problem that involves a ladder sliding down the wall. But this question is a little bit different from the usual question because it doesn't tell you the length of the ladder. So I'm just going to let the length of the ladder be L. The way we set this up is we pretend this axis here is the x-axis. So that's the distance from the origin, let that be x. And the height, which the ladder is leaning against the wall, be y. Okay, I'm going to use a convention that moving right is positive, moving left is negative. Moving up is positive, moving down is negative, which is a convention of movement on the coordinate system. Now, the information given says the ladder is moving down constantly at half. That means dy over dt, the change in the y is always shrinking at half feet per second. And the bottom of the ladder is sliding away. So dx over dt is 2 over 3. And they give us also that this is when the height of the ladder, which is y, is 16. Okay, we start from the Pythagorean theorem. X squared plus y squared will always equal to L squared, where L is constant, x and y are variables. Okay, differentiate all three sides, and we get 2x dx over dt, 2y dy over dt, and of course this is a constant, so it's going to equal to 0. So we get a simple condition, x dx over dt, y dy over dt is equal to 0 if you divide everything by 2. Now, what we ultimately want to find, at what rate will the bottom of the ladder be sliding away from the wall when the top of the ladder is 12 feet from the ground? So that right there is saying, well, when y is equal to 12, dy over dt is fixed to be negative half. But what is dx over dt? They didn't say anything about this as a constant. Okay. So in this equation, let me fill in what I know. So x I don't know. I don't know what dx over dt is. Y I know is 12. And dy over dt is always fixed, negative half. So this is what I like to find, but I don't know what x is. So we have to use this given condition here to figure what x is. Okay, and then we can find what dx over dt is. So let's plug in this information here into the derivative equation we found. So x in this case is not given. Dx over dt is going to be 2 over 3 when y is 16. Dy over dt is negative half. So that gives negative 8. So x is equal to 3 over 2 times by 8. Right? Bring that over 8 and then times it by both sides by 3 over 2. So you get 12. So if you plug in here that x is equal to 12 and y is equal to 16, right? L by Pythagorean theorem, right? You're going to get L is equal to 20. So x and y might change, but we just discovered that L is constant and it's always going to be 20. So in this second scenario, where y is equal to 12, clearly then, x will have to be 16. Right? So because here, when x was 12, y was equal to 16. It's swapped, right? So we can replace x with 16 now, finally. That's equal to minus 6. Solve for dx over dt now. 6 over 16. So 3 over 8. And the correct choice is B.